Okay, I'm happy to have you in our chemistry class. Okay, this is an introductory chemistry class. Welcome to the Supernovas TV. Here we learn all science subjects. Today we're looking at chemistry. We're looking at matter, states of matter. Before we look at states of matter, I want us to have an idea about what matter is all about. What is matter? Okay, matter, as we all know from definition, is anything that has mass and occupies space. Okay, so a football can be matter. Okay, from that definition, we can say a football is matter. Okay, we can say a table is matter. Okay, anything that has mass and occupies space is matter. All right, so everything around us, the rivers, water bodies, rocks, they're all matter made up of different components. Now, but this matter can exist in different forms. It can be in the form of solid, it can be in liquid form, it can also be in the gaseous form from here. Okay, now what are the properties of these different states of matter? Why will we say a state of matter is in the solid or gaseous or liquid form? What happens? What really happens? So let's go on. Let's take a sample of matter, for instance, and let's use water. Okay, let's use a body of water. You can see that if you look at this body of water, okay, under low temperatures, okay, water would freeze to become what? Solid. It will freeze to become solid. Okay, this solid is known as what? Ice. Okay, you have a ice block and then you say this, you play around with it before you know it, when the temperature increases, it melts. But what are the properties of solid state of matter? Let's look at taking ice as a reference point. Okay, now you can see in ice now is a solid. Now a solid has very strong force of attraction, strong force of attraction. Therefore, it's not easily broken because the particles are held very closely. You can't easily, unless you use something else or hit it before it will break. So it has strong force of attraction. Solids also have fixed, they have fixed shape. It can be rectangular, it can be a square, fixed shape and what? Volume. They have fixed shape and volume. Okay? That's for solid particles. Also, solid particles cannot flow. You cannot pour them to another container easily. That is, they cannot move easily because of the strong force of attraction. Okay, and also they have high density. They are very dense. Okay, high density. These are some of the properties of solid particles. Okay, we can also say that they are not free to, translate or to easily move about. So they stay in one place. They can only vibrate about their fixed position, but they cannot translate. They cannot. Okay, so those are some properties. Then what about liquids? Now you can see that if you take ice from your refrigerator, all right, and the temperature, okay, increases a bit outside, maybe room temperature, it will start melting to what? Liquid. So from solid we have what? Melting to liquid. Still using water as a reference point in this case. What happens in liquid? The force of attraction loosen up. You know, weak force of attraction. Weak force of attraction. So we say the particles are now a bit free to move about. Okay, the liquids can easily flow to another container. Okay, they don't have fixed shape. Take note, no fixed shape because they assume the shape of their container. No fixed shape. Okay, but they have fixed volume. They have fixed volume, but no fixed shape because the liquid can have the rectangular shape depending on this containing vessel. All right, no fixed shape, but they have fixed volume. They cannot be compressed. Yes, I remember. So solids cannot be compressed. It cannot because of the particles are on their own. Liquids too cannot be easily compressed. They cannot be compressed. Okay. So, but liquids are a bit free. They can vibrate and they can translate. Okay, but they cannot evaporate. They cannot easily leave out. Okay, the particles are still restricted in a way. That's for liquid particles. Now, what about gaseous state of matter? In the gaseous state of matter, they are very free. Okay, after melting, you have liquid. Then, when you continue heating, temperature increases again. You have what? Vaporization. And there, we can use steam as a reference point in underwater. Here, there is, okay, no force of attraction or negligible force of attraction. Force of attraction is very reduced. So the particles are very free. Okay, they are very free. They can move about. They exhibit random motion. Okay, gases can be compressed. For example, smoke particles. They are very free. You go into a room and somebody sprays a perfume, and you can it sends all around the room because it exhibits diffusion. Moves from the region of high concentration to the region of low concentration, and everybody will, wow, who came here with this kind of perfume? It's in a gaseous form. The particles are very free. They have acquired enough energy, so they are now free to move about, exhibiting random motion. That those are particles of what? Gaseous state of matter. They do not have restriction anymore. They can flow, okay? They are light, they are not, okay, no, not as dense as this, okay? They don't have force of attraction, yes, you said that, between them. They have acquired enough energy to make them free to easily evaporate and to move in random or zigzag motion. Now, these are properties of the states of matter. We have looked at solid, we have looked at liquid, we have looked at gas. Now, in the next class, we'll be looking at changes that matter undergo. What are those changes? We can look at physical and chemical changes. Matter undergoes those two basic kind of changes. Okay, essentially, what we have discussed here, states of matter, where we pointed out, as a change from one state to the other, and the properties, is under physical change because we can easily get back solids from gas. When the temperature goes down again, okay, of course, from gas to solid will be sublimation. That is a special case. But first of all, we can move from gas to liquid, which is condensation, and then liquid to solid. Okay, liquid to solid, which is this freezing. I hope you see it. Okay, so from solid now to liquid is what? Melting. All right. So these are the properties. I said in the next class, look at the physical and chemical changes and examples of such changes. Chemical changes, those are chemical processes. For example, roasting, combustion. Look at all that. I hope you had a nice time in this class. I will look forward to seeing you in the next class. Okay, I'm your tutor taking you physics, chemistry, and mathematics, both on Facebook, the Supernovas Academy, and on YouTube, the Supernovas TV. I'm looking forward to see you in the next class. Okay, don't miss it for anything.